Okay, we're coming on to the problem-solving part of the paper now. And this is a bit where we have to really start reading questions carefully. So, the population in England was approximately 53 million. It is predicted that the population in 2018 will be 4% more than the population in 2013, and the population in 2023 will be 4% more than the population in 2018. Work out the predicted population of England in 2023. Okay, so between 2013 when it was 53 million, it will, so if I write that down, so in 2013 it's 53, and you know what, I'm going to write out million, that's 6 zeros, isn't it, 53 million, and then that the population in 2018 will be 4% more than the population in 2013, so in 2018 it's 4% more, plus 4%. Okay, so that's a multiplier of times 1.04. We could do that. We could do that straight away if we want. So 53 million. Check it. 53,000,000 times by 1.04 equals 5512000. So the key thing here is now accuracy. I do not want to round it or anything like that at this point. I'm going to keep all of my accuracy. So my population in 2018 would be predicted to be 55,120,000. Okay. And the population in 2023 will be 4% more than the population in 2018. So we're going up 4%. Again, it's another multiplier of 1.04. So I'm going to take that 55,120,000 and I'm going to times it by 1.04. And there's my answer to what the population would be in 2000, or what it would be predicted to be in 2023. There it is. So I'm going to write that down carefully. 57324800. Just really carefully check that. Put the commas in. Right, 57 million. I'm sure I got the right amount. So is that right? Is it work out the predicted population of England in 2023? Okay, so I'm happy with that. 57,324,800. Now, I could have gone straight there, couldn't I? Because I could have said there's an alternate method. I'm going to say M2, method 2. I could have gone 53 million. I could have spotted that it was 4% increase both times. So it's times by 1.04 twice, so I could have just done it like that. And I would have gone straight to the answer. So let's just check that on the calculator. 53 times 1.04 to the power of 2. There it is, it's the same answer. 57,324,800, that's my answer. Okay. Right, now this is one that did confuse many people. What is the overall percentage population increase from 2013 to 2023? So in 2013, it is this amount. 2023, it's that amount. What's the percentage increase? Well, to find a percentage increase or decrease, I need to work out what's the change divided by what was my original amount, and that will give me the decimal equivalent for the percentage. So I can just times that by 100 to get my percentage increase or decrease. Okay, so my change is from 53 million to 57,324,800. I could put that into the calculator and do it. Right, but actually, I can do that mentally. I can see that from 53 million to 57 million is 4 million, so it must be 4,324,800. So my changes, please by all means check that with a calculator. 324,800. You have a calculator for this, so you can. divided by my original amount, which in this case is 53 million. Okay. That will give me the percentage change as a decimal, so I'm just going to times that by 100. That is going to be my answer. So let's write that down. Let's get that in. So 4,324,800, 4,324,800 divided by 53 million equals, okay, change that to a decimal, 0.0816. So that is a decimal. That's it as a decimal. I can change that to a percentage just by multiplying by 100. You could have just spotted this anyway. It's 8.16%. The question has not asked me to round it, so I'm going to leave that as 8.16%. It's also important that it's not that I don't just write 8%, because you know, you could have just arrived at 8% by saying, oh, 4% more and 4% more again. It's a bit more than 8% because the second 4% is of a higher value than the first 4% was taken from. Right, that is question 5 on the problem solving. And I do have an improvement question for you to do if you didn't get an element of that question correct. So there's your working out for you to use and help you. And here's a very similar question which I'd like you to complete in your book on the next page, please. So here it is. So I need you to write improvement question 5 and copy the question below. Then answer it showing full working. So here's the question below. Here's the question. The number of bees in a hive was 650 in 2012. Between 2012 and 2015 it increased by 20%. It will increase a further 15% between 2015 and 2019. Work out the predicted population in 2019. And that's the part A. Part B, what is the overall percentage increase in population between 2012 and 2019? So I need you to copy that question in and complete it showing full working, please, to make sure that you've put any difficulties you had in this question and you've learned from them. So if you needed to correct either of these, you must complete this question. You can pause the video on it while you copy it. Okay. Right, let's have a look at this one then. Question 6. The table shows the consumption of water per person on average each day during various years. Right, but we're missing 1960. 110 litres on average consumption per person in 1976. 150 in 2004, average consumption per person. And then there's 2021. Okay, a 26% increase in population is predicted from 2004 to 2021. So this was generally very well done because it's a very straightforward application, isn't it? So I'm starting on 150. 26% increase, remember that's 100% plus 26%, which is 126%, which is 1.26 as a multiplier. So 150 times by 1.26 equals, let's put it in here, 150 times by 1.26 equals 189. Let's not forget the units, 189 litres. I'm going to put that in here as well for the sake of it, 189. Okay, calculate the percentage increase. So we're looking again now at what we were looking at here. The percentage increase, again this time in consumption from 1976 to 2004. So it's just between these two. Right, what did I say about percentage increase? It's change divided by original amount. That gives it as a decimal, and I'm just going to multiply it by 100 to turn it into a percentage. So therefore, I'm going to use my therefore sign. My change is 110 to 150. My change is 40. My original amount, so it was from 1976, so my original amount was 110, and I'm just going to times that by 100. That will give me the percentage increase. Right, so let's put that into the calculator. 40 divided by 110 equals, oh no, I did times. 40 divided by 110 equals 4/11 or 0.36. Now look at, they've got little dots above that. So it's 0.36 recurring. Okay, so that means that's 0.363636 going on forever. So, I mean, the question hasn't asked me to give a cutoff point, but I'm going to say, which is equal to, so I can times that by 100 to turn it into a percentage. So I will do that. Times by 100. Okay, so 36.36, and it goes on forever. So it's 36% to the nearest percent, or it's 36.4. Careful, 0.4 if it's to the nearest one decimal point. So I'm going to call it 36% to the nearest percent. Okay. Right. Last question in the problem solving. The consumption in 1976 was 20% more than the consumption in 1960. Calculate the consumption in 1960. The really important bit here, guys, is to realize that what we are talking about now is finding an original amount. It started off in 1960. There was an increase of 20%, and that gave us 110 in 1976. So let's set that out. We've got the original amount, or the original consumption. We've got a 20% increase. So what's the multiplier for a 20% increase? It's times by 1.2. And that gave us 110 litres in 1976. So to find my original, I'm going to reverse the process. So I'm going to take 110, and to go backwards I'm going to do the opposite. So I'm going to divide it by 1.2, and I'll find my original consumption. It's not the same as, dividing by 1.2 is not the same as timesing by 0.8. So that's the key mistake that people make. When you're finding the original amount, set it out like this and reverse the process. So 110 divided by 1.2 equals 91.6 recurring. 91.6 recurring. Okay. So that's the same, and I'm going to just write that as 92 litres to the nearest litre. And that's all of the questions on the problem solving, but do not stop the video, because I would like you to complete an improvement question, and this is it. Okay, if there was some questions here that you didn't get correct, and I would suspect it would probably be this one and possibly this one, then you need to complete this improvement question. So this one, I've just made a similar question about energy usage. So energy usage in spring, summer, autumn, winter. Energy usage goes up 80% between autumn and winter. How much energy is used? So you copy this table in, and you complete the questions below showing all working out. Energy usage goes up 80% between autumn and winter. How much energy is used in winter? That's part A. Copy the question, complete your working out carefully, complete the question. B. Calculate the percentage increase between summer and autumn. And C. Energy consumption reduced by 20%. Reduced by 20% between spring and summer. Calculate the consumption in the spring. There we go. So pause the video on that and good luck. Next section is the reasoning.